Howdy everybody, and welcome back to our Chip and Dale tutorial. So today we are going to come back to our player object here, and we are going to start adding in some states so that we can move our player character around and start interacting with the world. So let's get cracking. Alright, so what we got here is our player object, and we have added in some interesting information in our create event that'll all be useful later on. So let's start with the step event here. And in the step event, we are going to want to add some things here. Let me see what I want. I got a bunch of pause information here, but I'll skip that for now until we actually put in pause objects. So, to start us off then, we will just move with event underscore user state. So that'll be our execute state. And a second thing here, if not manual underscore sprite underscore change, then sprite underscore index is equal to sprite state underscore direction underscore facing. So this is a new variable I came up with. It allows us to, every frame this gets set back to true, I believe, but in our it gets set back to false every frame. But if we have a step where, if we have a state where we want to manually handle the sprite change, because say we want to do a custom animation, which we use for like picking up objects, then we will set it to true so that it doesn't set our sprite to whatever the sprite index should be, because this will allow us to do animations with our sprites. Animate sprites if needed. Alright, so that'll be useful in the future. Let's go back to our begin step here. And let's see here. We got a lot of stuff going on here, but at the same time it's kind of easy, but at the same time it all goes in with our collisions and stuff. Let's see, yeah. We'll start with this. Region inputs. We need to be able to check for our inputs. So X input is our object input right check minus left check. Y input, object input dot down check minus up check. Jump input, did we get a action pressed? Jump held, is it being held? Pickup input, select input, and start input. And of course, our direction facing. So create a point direction from 0, 0 to X and Y. So if our X is 1, so that'd be going right, and our Y is 0, then this will create a point direction that faces right. It'll give us a value of 0 back. It'll give us an angle of 0 back. If Y input is 1 and X input is 1, then that will give us a value of 45 degrees back. But we are going to round down, so it would give us right, I believe, instead of 45 degrees. So don't change my facing direction unless I actually am moving. So if my X input or my Y input does not equal 0, then don't do this. Direction underscore facing is equal to round the input direction divided by 90. So this would give us our enum, so to say. So we so we got 0 divided by 90 over here. That would give us 0. So that would be, and as we know from our macros, we have dir4 right is equal to 0, up is 1, left is 2, down is 3. And if direction facing is equal to 4, then we go back to 0 on that, since that is right. And we're just going to toss this in here. Manual underscore sprite underscore change underscore is equal to false. That'll be setting our manual sprite change flag back to false. And you might remember from our last tutorial that we also have an on-ground check that happens here as well, and we have that coming up as well. But first, I think we'll set up our move state. So let's come over here and add a user event 0. Alright. So we're going to have a couple different regions here. Region states, end region, and region collisions and movement, end region, and pound region animation, end region. So let's start with the animation. Our image underscore speed is equal to animation underscore speed while we are in this state. And if our x underscore speed underscore is equal to 0, so if we're standing still, then image underscore speed is equal to 0. Manual sprite change is equal to true. And our sprite index should be equal to s underscore get underscore index sprite underscore plus character name plus underscore idle. And that's how we get our idle state while being in the move state. So we don't have to have an actual idle state. And if x underscore speed underscore, though I mean I guess we could have an idle state. I don't know if it'd be much different. So if we're moving, then image underscore x scale is equal to the sine of x underscore speed. So our character only has a right facing sprite, so when we are moving to the left, we need to flip our image x scale. So that's what we got here. Let me open this up real quick. Yeah, so I centered this at 9:8, and that make it so that you have a seamless flip when you move your character around. Alright, so that's it for animations. For states, well, we don't have any other states yet, but you'll remember that what we do is we fit all the information we need into the states area so that we can swap our state at need. So we'll come back and fill this in as we add more states. Alright, so next up would be our collisions and movements. Let's see. If x underscore input underscore does not equal 0, x underscore speed underscore is equal to approach x underscore speed underscore max underscore speed underscore times sine of x underscore input underscore Excel. Alright, so we're going to approach our x speed towards our max speed times the sine of our x input. So if we're going left, again, this will give us a negative value by our Excel value. And else x underscore speed underscore is equal to approach x underscore speed to 0 via friction. Alright, then next up we have our y speed. Y underscore speed underscore equal to approach y underscore speed underscore to fall underscore speed underscore by gravity. Probably don't really need this here, but I have it there because it doesn't really hurt anything. But it shouldn't really be necessary. I mean, if we are in a position where we're actually needing y speed, then we should be off the ground, and in that case we'll be in the jump state at that point. Alright, so next up would be our speed fractions. So let's see, if y underscore fraction underscore does not equal 0 and we are on the ground, then y underscore fraction underscore is equal to 0. So that should, if x underscore fraction does not equal 0, and x underscore speed underscore is equal to 0, and x underscore fraction underscore is equal to 0. Those are two, whenever we are stopped, just remove all of our x fractions and y fractions. Then next up, we add our fractions. And store fractions. Alright, so our x fraction is equal to, that should be a minus, x fraction is equal to our x underscore speed minus the floor of the absolute value of our speed times the sine of x underscore speed underscore. So let's see, back here, I set my acceleration to be 1.75. So that means we are not getting a complete acceleration, and of course our friction is 1.75 as well. So that means on our first frame of moving, we would have an x speed of 1.75 because we've approached our max speed by 1.75. So what this does is it trims off that 0.75 and saves it until the next frame, where then it gets re-added back on to our current speed, and then will let us move instead of one frame, instead of 1 pixel, we move on the next frame, we move 2 pixels. And the next frame we move 2 pixels, next frame we move 2 pixels, or something like that. And then you go back to moving 1 pixel. And this allows us to move at the same rate as the characters in the game. And I know this works because I watched it frame by frame as they moved, and I calculated their speed based on how many pixels they move each frame, and this was the value that I got out of all that. So then we go x underscore speed underscore minus equal x underscore fraction. So this will calculate that 0.75, and this will subtract the 0.75 from our x speed. And we do the same thing for our y speed. All right. Let's see. And that should be the end of our speed. Oh, wait. Forgot that there, and forgot that there. Because I'm a silly-nilly with my parentheses. So we got that. And we got that. So now that the speed fractions are over, we can start applying our speed to our character. So our underscore speed, I'm going to declare that underscore speed is equal to layer underscore move underscore width underscore object underscore collisions and underscore solid x underscore speed y underscore speed. And we haven't made a parent solid yet, so just go over to your, let's see, where did I put parent solid? Oh yes, it'd be in the parents section. And yeah, we don't do anything with it. We just create it. And anything that's solid, we will connect it with that. We use this for all of our pick-upable objects that are lying around the game. In fact, I could probably even get rid of this completely if I changed those all to tiles and use tiles instead of objects. But you can't use tiles instead of objects because specifically the steel crates, they can be placed in such a way that they do not connect with the grid. So since they can do that, that means that they are objects and not tiles. Alright, let's zoom back in again. And so we have to check for collisions with solid objects. If you want to get the big, if you want to know what's all going behind the scenes here, you can, if you want a really in-depth version of what's going on behind the scenes, you can check my channel for my tile and object collisions tutorials. I'll go over this in a second here, but that would be the super in-depth version. And player underscore move underscore width underscore tile underscore collisions. Tile map underscore x underscore speed and y underscore speed. Tile map was declared back over in our create event. Getting our collisions layer. x underscore speed underscore is equal to underscore speed 0. Y underscore speed underscore is equal to underscore speed 1. Each of these scripts returns an array with 0 being our x and 1 being our y. So let's go into these scripts real quick. And come on, there we go. Alright, I'll give you a real quick lowdown of what's going on inside these things. So we have our script that's being passed a couple of variables, what we want to collide with, what our x speed is, and what our y speed is currently. And what it spits back out is what our x speed and our y speed needs to be, depending on whether or not there's actually going to be a collision. So if we're moving at 2 and there's a collision with a wall in 2 pixels, but there's 1 space between us and the pixels, it would return an x speed of 1, so that then we'd move that 1, and then our next well, actually, it wouldn't do that with this one, because this would actually snug you up against the wall and return a 0. So yeah, so place meeting x plus x speed y object, so that'd be our collision object. Then it would snug us up to the wall via x plus equals sign of x speed, and then set our x speed to 0, and at the end down here it returns the x speed. Then same thing for for this, we comment out the x, y plus equal right here, because we are just checking for the collisions. We're letting the tile movement script here do the actual moving. So that would be the next one at that point. Though really, I probably don't even need to do this, now that I think about it. Oh well, I'll come back to that again in my next tutorial probably, and make that work even better. Again, with the vertical collisions, while not place meeting, again, move us over, then set our y speed equal to 0. The more complicated version here is the ledge check. Because our ledges, so only need the ledge check if we're moving in both x and y. So that's a little bit of optimization there. So if the y speed is greater than 0 and we find a ledge via edge checking here, then we move in the x direction and move in the y direction. Else, when we are going up, again, reverse it. So check in a y direction, then check in the x direction. And try to move ourselves so that we collide properly with the ledge, and then we leave. Let's come over to the tile collisions. Tile collisions are pretty much the same, except if we're going to run into a wall, snap into it instead. Instead of using the +1 pixel snug, we can literally just snap to the edges, because we know exactly where tiles will be because they align with the grid, as opposed to objects which can be anywhere. So if x speed is greater than 0, then we are checking on our right for a collision, else we are checking on our left for a collision. And we find out what the current cell our character is walking in, what the target cell, how far away we're going to be moving is, and that would let us know whether or not we're actually going to be leaving the cell, because if we are going to leave the cell, then that means that we actually have to check for a collision. But if we are in the same cell throughout the entirety of the movement, then we don't need to check for a collision, because there's not going to be a tile inside of our cell. And this would be how many cells to check for a collision. So if we have a target cell, if we're 50 cells away from our current cell, then this would tell us to loop through our tile collision check 50 times so that we can check every single cell between us and our destination to see if there are any collisions between where we are and where we want to be. So that way you can move as fast as you want to and you won't run into anything. Or you will run into what you want to run into. Alright, if we are not leaving the current cell, no need to check for a collision. As you can see, I've heavily commented all this, so hopefully you'll be able to read from it fairly easily. So this would just be x plus equal x speed at that point. Else, and for each one of the cells to check, then check to see if if there's a cell there that we don't want. In this case, we have solid blocks and we have spiny blocks. So let's see with the 1. And in either case, if we detect either one of them, we get snugged right up to it via this little bit of code here. And if no collision is detected, then we just apply our speed as normal. And the same thing goes for our Y speed. It's all pretty much the same code at that point. And going up. The only difference being if we hit a platform, this allows us to go through a platform when we are going up, as opposed to when we are going down, we will land on a platform. And if our current cell does not equal the target cell, so if we haven't reached the cell that we want to be in yet, then we will not be able to get stuck inside of our platform block. And yeah, return our tile speed. Alright, so anyways, you can see all this code there. That should all be working properly. Characters should be ready to go. Let's go give him a check, see how well he moves. And there we go. We're able to walk left and right, and we are moving with respect to the ground. Alright, so next up we are going to be adding some more states, such as our duck state, the carry move state, throw state, jump state, hiding state, etc. I think we'll probably do the jump state next, since that's the one that most people actually need. Alright, thank you everybody for joining me, and if you have any questions, don't hesitate to leave a comment, and good luck with your programming.